Bismillahirrahmanirrahim. Welcome to topic 4.4 thread libraries. We discussed this topic using two videos. This is the first video which we discuss about general topic of thread libraries, and the second video we will discuss about thread creation using Java. A thread library provides the programmer with an API for creating and managing threads. Two primary ways of implementing a thread library. The first one is to provide a library entirely in user space with no kernel support. So this all code and data structure for the library exists in user space. And this means that invoking a function in the library results in a local function call in user space, not a system call. The second one is to implement a kernel level library supported directly by the OS. So in this case, code and data structures for the library exist in kernel space. So invoking a function in the API typically results in a system call to the kernel. Three main thread libraries are used in today. We have POSIX pthreads, Windows and Java. Pthreads is the extension for the POSIX standard, may be provided as either a user level or a kernel level library. The second one is Windows thread. So the Windows thread library is a kernel level library available on Windows system. The last one, Java Threads API, allows threads to be created and managed directly in Java programs. So however, because in most instances the JVM is running on top of a host OS, the Java Thread API is generally implemented using a thread library available on the host system. For example, implementations of a JVM for the Windows OS might use the Windows API when creating Java threads, while Linux and Mac OS system might use the pthreads API. Before we proceed with thread creation in the next video, we discussed two general strategies of creating multiple threads. We have asynchronous trading and synchronous trading. So for asynchronous trading, once the parent creates a child thread, the parent resumes its executions so that the parent and child execute concurrently and independently of one another. So because the threads are independent, there is a typically little data sharing between them. So asynchronous trading is the strategy used in multi-threaded server. Remember, multi-threaded server is the example we already discussed in topic 4.1. And asynchronous trading is commonly used for designing responsive user interface. For synchronous trading, it occurs when the parent thread creates one or more children, then must wait for all of its children to terminate before it resumes. Here, the children thread perform work concurrently, but the parent cannot continue until this work has been completed. So once each thread has finished its work, it terminates and joins with its parent only after all of the children have joined can the parent resume executions? So typically, synchronous trading involves significant data sharing among threads. So for example, the parent threads may combine the result calculated by its various children. So that's all for the threads library. Thank you and see you in the next video.